As we have seen the definitions of phenol in the first class, phenols are the hydroxy derivatives of benzene. That means replacing the hydrogen atom of the aromatic hydrocarbon by OH group, we are going to get the phenols. So phenols are formed by replacing hydrogen of an aromatic hydrocarbon by OH group. In this, OH group is directly attached to sp2 hybridized carbon atom, but it should be in the aromatic only. If it is in the aliphatic, then again we are going to call it as a alcohol. Phenols are commonly known as carbolic acids. The common name for the phenol is carbolic acid. Let us see the classification. Based on the number of hydroxyl groups, phenols are classified into 4 types. First one is based on the number of one hydroxyl group, that is monohydric phenol, dihydric phenol, trihydric phenol and polyhydric phenols. Just as it is in the alcohols, monohydric alcohol, dihydric alcohol, trihydric alcohol and polyhydric alcohol, but here alcohol is replaced by the phenols. First let us start with the monohydric phenols. Monohydric phenols, as the name itself says, they contain one hydroxyl groups. When there is a presence of one hydroxyl group in the phenol, then it is called as a monohydric phenols. Definition: phenols in which they contain one OH group per molecule is called as phenols. One of the simple example which you have came to know regular life, that is cresol, they are the monohydric phenols only. Let us see some of the examples. First one, containing only OH group directly attached to a benzene ring, that is your phenol. In other words, it is also called as hydroxybenzene. Now we will go for the substituent groups like CH3 attached to OH at the second position. When CH3 is attached at the second position, that is methyl group, so we will call as a 2-methyl phenol and its common name is orthocresol. If the CH3 is present at the third position with respect to OH group, then it is called as 3-methyl phenol or metacresol. If the CH3 is present at the fourth position with respect to OH, then it is 4-methyl phenol or paracresol is the common name. Second class, that is dihydric phenol. As the name itself says, di means 2, hydric OH phenols. Phenols which they contain 2 OH group per molecules are called as dihydric phenols, or they are also called as dihydroxybenzenes. Examples: directly benzene having the 2 OH at position 1,2, benzene 1,2-diol, or common name is catechol. If the OH are at the position of 1,3, then benzene 1,3-diol, or common name is resorcinol. Now I will extend it. OH are present at 1,4 position, then they are called as benzene 1,4-diol, or common name is quinol. Quinol, you should remember, it is very important compound. Why you will come to know in the subsequent classes. Quinol is again converted into quinone and it is used in the some of the medicines and all. Hence it is very important. Now we will go for the third classification, that is trihydric phenols, which contain 3 OH group per molecule. That is phenols in which they contain 3 OH group per molecule are called as trihydric phenols. They are also called as trihydroxybenzene. Example: 3 OH are present at 1, 2, 3 position. Name is benzene 1,2,3-triol, or common name is pyrogalol. 3 OH are present at 1, 2, 4 position, that is benzene 1,2,4-triol, that is hydroxyquinol. And 3 OH are present at 1, 3, 5 position, that is called as fluoroglucinol. These are the some of the simple examples. For polyhydric phenols we are not going, because polyhydric phenols, the 4OH or 5OH will not be present at the single benzene ring. They are complex structures. At your level it is not there. The second class of the hybridization is based on the hybridization of carbon atom to which hydroxyl group is attached, that is compound containing carbon with sp3 hybridization OH is attached. They are basically not called as a phenols, but they are called as a benzylic alcohols. Since aromatic ring is present, I have taken once again, already you have studied the same thing in the alcohol chapter. When OH is attached to sp3 hybridized carbon atom next to the aromatic ring, that is called as benzylic. And since OH is present at the aliphatic chain, even though aromatic is present, but OH is attached to aliphatic carbon, that is benzylic carbon, hence it is called as a benzylic alcohol. The first one is benzylic alcohol, name itself is there, that is primary one. If I am having one more CH3, then it is secondary, 2 CH3, then it is called as a tertiary. Now the most important, that is compound containing sp2 hybridized OH bond, that is OH is attached to carbon with sp2 hybridization of benzene ring. sp2 hybridization of benzene, remember here. If it is sp2 hybridization of the aliphatic, then it is called as vinylic. But here it is benzene, hence it is called as phenol. OH group is attached to sp2 hybridized carbon atom of an aromatic ring. Example is simple phenol. Second one is OH and CH3, that is your catechol, already you have studied. Now we will go for the IUPAC nomenclature. The IUPAC nomenclature of the phenol is very easy. When it is a monohydric phenol, that is containing only one OH, they are directly referred as a phenol, and the substituents will be taken as a prefix. For example, methyl is there, then methyl phenol. If ethyl is there, ethyl phenol. If you are having some other substituent like propyl, nitro, amino, then aminophenol, nitrophenol, like that it will be continued. That containing the substituents will be having the prefix along with the phenol. But remember, the substituent phenols, whenever they are there, the position should be very careful. You cannot skip the position of the substituent groups. That's what we are studying in the dihydric phenols. The dihydric phenols containing the two hydroxy groups called as benzene diols. But here also position is very important. We have taken some of the examples in the previous slides. Benzene 1,2 diol, benzene 1,3 diol, benzene 1,4 diol. 1,5 is not possible, 1,6 is not possible, because when it is 1,6, again it is a position of 1,2, the lowest sum rule. If it is 1,5 you are saying, that is not actually 1,5, it is 1,3, because according to the lowest sum rule, the numbering should be from the left hand side. Like that it will be continued. So trihydric phenols, benzene triol. Here also position of the OH group must be mentioned by the numbers. If you are not mentioning the number of the OH groups or the position of the prefix or the hydroxyl group or the methyl, ethyl, any of the substituent, that does not carry any marks. Let us see some of the examples. Compound, IUPAC name, another compounds and IUPAC name. First one OH, that is your phenol. I have taken CH3, that is 2-methyl phenol. CH3 at the position 3, then it is 3-methyl phenol. OH and CH3 at the fourth position, then it is called as a 4-methyl phenol. Already you have studied all these examples previously. Now we will take some more example containing the 2 OH groups or 3 OH groups. When benzene with 2 OH group at the position of 1,3, then it is benzene 1,3 diol. 3 OH group. 1 2 3 position, hence it is benzene having 1 2 3 triol. 3 OH group at the position of 1 2 and 4. Can you guess the name now? Benzene 1 2 4 triol. And benzene with 3 OH group at 1 3 and 5 position, then it is benzene 1,3,5 triol. One more example of containing 2, benzene 1 2 diol. One more 1 2 3 4 position, that is benzene 1 4 diol. Next I will take different substituents like bromo. So bromo is present at which position with respect to OH? Position 2 and 4. At position 2 and 4 bromine is there and phenol is there. Hence 2,4-dibromophenol. Bromo will become the prefix. Similarly, if I take the nitro group, but 3 nitro are there at the position 2, 4 and 6. Hence the name is 2,4,6-trinitrophenol. Thank you.